Hello. This question addresses the addition of the two waves, the overlapping or the superposition, whatever word you have heard in your class. This question is about the addition of the two waves. So basically, this question is directly addresses the concept of superposition, principle of superposition. So first of all, I clear you the concept of principle of superposition, which states that if the two waves overlap, if two or more than two waves overlap with each other, then the resultant wave's displacement is the algebraic sum of the displacement of individual waves. No problem. I will show you the diagram, especially the diagram of this question. So what we see in this question that the two pulses, this pulse and the pulse, which are both identical in shape, they are traveling opposite of each other. So at some point they will start overlapping with each other. They will add up, and then what will be the shape of resultant pulse? That's what we have to choose from one of them. So this pulse is traveling in this direction, whereas this pulse is traveling in this direction, whereas they are moving on a same medium. Okay, so what you see here that let's say it has traveled a little bit distance to the right, okay, and it has traveled to the distance to the left, like this. And right now, this must be this must be here. Exactly, they are about to overlap. Right now, they are not producing any wave because they have not started overlapping. They have not started superposing with each other. In the next diagram, I'm going to show you their maximum overlap, their maximum superposition, and that can happen only when these two pulses will be over on each other perfectly. They will sync with each other. So see here, I have tried to show you like this. Okay. Now they will produce the same shape of pulse, but the difference will be just the amplitude of that pulse will be the twice of the amplitude of the single pulse. So, dear students, it means that the resultant pulse must be something like this. Okay. So, this is your resultant pulse. So the right answer should be option A, not B, C, or D. Okay. But might be if you are thinking that if I have skipped something, that what happened when those two were not perfectly overlapping, when they were combining with each other. So that's I thought I will show you at that place that what will happen. So actually, if you see this part, if you see this part, that in this part the displacement is not equal, it is increasing. So why it is increasing? When the two waves are getting close and now they started overlapping, so their displacements are adding up. Okay, I show you. And to clarify this concept, I am showing you the three shapes which are happening at the three different times when they were getting close at initial time, like they are at this point. Okay. So their both displacements will add and they will give you this point of the resultant wave. Okay. Now when they will get more close, so now you see that at that point, if you add the individual displacements, then it might represent this point of the resultant wave. And in a third, at a later time, if you see now, they are almost very close to perfectly overlap with one another. At that point, their resultant displacement will represent this point of the resultant wave. And finally, they will be in this form, and then they will produce this type of pulse. So I hope you understand this solution.